GetSet.com. GetSet.com.
Howdy, howdy, howdy. Welcome to the lesson on classes and objects. Now is when we get into object-oriented programming, or OOP, my favorite part of the class. Classes and objects. Classes are what we create in order to build objects. A little history lesson for you as far as PHP is concerned. PHP did not start out as an object-oriented programming language. Version 1, version 2 were not object-oriented at all. That's why we start this class learning about functions and variables and non-object-oriented PHP, because there's still a lot of code out there that doesn't use classes and objects at all. Version 4 of PHP had object-oriented structures built into it, but it wasn't full object-oriented. It wasn't robust object-oriented programming. It's not till you get to PHP version 5, and that's quite a few versions into it, that PHP really starts to round out as an object-oriented programming language. Keep that in mind, that how you code in PHP is very dependent on which version of PHP you're using. And we'll point out a few of the things in this lesson, differences between 4 and 5 and things of that nature as we go along. But now it's time to get into objects, because PHP 5 plus, we're doing objects. A class is to an object. A class and an object are very related, but they are not exactly the same thing. A class is to an object like a blueprint is to a house. A blueprint is a complete specification for creating a house, but somebody has to take that blueprint and make a house out of it. A class is to an object like a recipe is to a cake. What is a recipe? It's a complete set of instructions and ingredients for creating a cake, but the recipe doesn't become a cake until somebody gets in the kitchen and bakes it. A class is a definition or blueprint for creating an object, and the reason we create a class is in order to build objects out of it. Can you declare a few variables? I think you can. You're deep enough into this class that you've been creating variables. Can you write a few functions? I hope you can. At this point, you should know what a function is and how to build one. That's it. Those are the two things you need to be able to do. You need to be able to declare some variables and write a few functions, and you can create a class. We're going to create a class enemy here. And see that open curly brace? That is the start of the class enemy. See that closed curly brace at the bottom? That'll be the end of class enemy. This is a fairly consistent line of code. If I'm going to build a class enemy, this is what it'd look like. If I was going to build a class car or class monster, all I'd do is swap enemy for car or monster. It's pretty easy. The keyword class is a requirement. In order to create a class, you're going to have to use the keyword class. This is the name of the class. Again, that's the only thing that changes from class to class. Every time you build a new class, you will give it a different name. Again, just like variables and functions, give it a good descriptive name. If it's going to represent a car, call it car. If it's going to represent a monster, call it monster. Do not use short, cryptic names for your classes. What do you do inside the class? Well, inside the class, hopefully at the top, it's not a requirement, but hopefully at the top of the class, you declare the variables. You declare the variables that describe what the object is. What is an enemy object? Does it have an X and Y position? Then that should be its variable. Does it have a health value? Then it should have a health variable at the top. The information that describes what the object is should be contained in the variables that you declare at the top of the class. Remember, a class is used to build an object, so any variables you declare at the top of the class will end up being the variables inside your object. Now let's write some methods. Let's write some methods to manipulate those variables. You know how to write functions. You've written functions for this class at this point, I hope. Write some functions that describe what this object does. Is it enemy attack? Then there should be an attack function. Does the enemy bleed? Then there should be a bleed function. Anything that an enemy object intends to do, you want to write as a function inside the class. And if you create it as a function inside the class, it will end up being one of the functions that are part of the object when you go ahead and create the object. The curly braces are a requirement. Anything that is after that open curly brace, but before that closed curly brace, will be part of the class. And if it's part of the class, it will be built into the object that is created from that class. Knowing where your opening and closing curly braces are important. If you put them inside, it'll be part of the object. If they're outside those curly braces, it won't be part of the object. A little arrow with run program written there, because that is one of the biggest distinctions between a class and an object. An object is a runtime entity. If I'm working on my computer typing code in, I'm definitely working on the class. But if the program is running and executing, then I can have an object. You understand what I mean by runtime entity? When you execute the program, that's when the objects get created. So an object is kind of like a variable in memory. It gets allocated, it takes up space. An object is like a variable. It's been created and boom. What is in that object depends on the variables and functions you put in the class. Everything that you define inside the curly braces of the class will be in that object. And once again, I can't stress this enough. An object is a runtime entity. I don't care. If your program is not running, you don't have an object. It's just a brief overview of classes and objects. Let's look at an example right now. Writing a class. Let's create a class from scratch. Let's build a new class to represent an enemy in a video game. Quite often enemies have conflicts where you do battle with some creature. Who knows what creature it is? This is your enemy during the video game. You're trying to kill it, and it's trying to kill you. We need a class enemy in order to build enemy objects. Before we can create an object, we have to write a class, and the class is our definition or blueprint for building an enemy object. As I said in the previous slide, we're going to create a class enemy. That open curly brace is the big fat signal of the start of the class, and anything after that curly brace, but before the closing curly brace at the end, is going to be part of the enemy object when we build it. This is a very consistent pattern. When you build a new class, all that stuff that you see underlined and boxed in red, it's all going to be there, except the name of the class will change. This is the class enemy. When you build a class car, you'll substitute car for enemy. Variables. Now, technically, you don't have to put them at the top of the class, but I'm going to insist. I'm going to insist for projects in this course, you put your variables at the top of the class. The problem with putting them at the bottom or the middle is you can't find them. And I always like to see them right at the top so I understand what I'm dealing with. Also, let's introduce a new term called a property. Remember, PHP can be programmed in non-object oriented or object oriented. The variables that we declare outside the class, let's keep calling them variables. But in object oriented terminology, we like to call these things now properties. And that property is just a term that indicates it's a variable that's part of a class or object. So you'll hear me use variable over and over and over again, but the proper object-oriented term is a property. It's an element that represents the object. We'll use variable a lot, but try and start calling the variables inside of a class / object properties. What does this tell us? This tells us that an enemy has an X and Y position on the screen. On the X axis and the Y axis, we need to keep track of where that enemy is to be drawn on the screen. Also, since we're trying to do harm to this enemy, we're going to have a health variable. That health variable, if it's high, it means the enemy's surviving, it's doing well. If that health variable gets low, it means we've done a lot of damage to it. And of course, if that health goes to 0, maybe that enemy should die. This is the information that describes what an enemy is. That's X and Y coordinate and how healthy that enemy is. In the red box are the functions. We have what's called a constructor function. We have a set X position. We have a get X position. These are the functions. These describes the actions an enemy object will take. Again, in object-oriented terminology, we have a new term. Methods. Ooh, Why do we call these methods? Well, again, to separate it from the functions that are not inside a class or an object. Remember, a variable outside of a class is called a variable. Put that same thing inside a class, we want to start calling it a property. Same thing for functions. Obviously, these are functions. You see the keyword function. But since they're inside a class, we want to use the term method so it implies that they are part of the object that we will be building out of this class. Object-oriented programming terminology. We like to call these methods. Lots of people call them functions, so don't feel bad if you find yourself calling these things functions. They are functions, but they're functions that are part of a class/object. There's a special type of function called a constructor. This is constructor function or constructor method. Constructors build objects. Usually they initialize the variables or properties. This is a new type of constructor that was introduced with PHP 5. That's an underscore underscore and then the keyword construct. Name it that way, and this will run as soon as an object is built out of class enemy. Who takes a blueprint and creates a house? A construction worker. Who takes a blueprint or a class and builds an object? A constructor method. Constructor methods are the methods that are run first to help build the object. And again, this is PHP 5 and later. If you are using an older version of PHP, this might not work as is. We'll look in the next slide how to do it pre-PHP 5. But for now, if you're in the later version of PHP, this is how you want to build a constructor. And you can see it's initializing X position, Y position, and health. That's what constructors do. They initialize the properties or variables of the class. Here's a regular method, sometimes called a setter method. And what setters do is they put values in objects. Those variables up there like X position, if we want to assign a new value to it, we're going to call this set X position method and pass it the value we want to assign to the X position variable. This is called a setter or set method, and its job is to put values into the object's variables. Next up is called a getter, get X position, sometimes called a get method. Getters pull values from objects. Objects are like super variables. You can put stuff into them and you can pull stuff out of them. Setters put data into objects. Getters pull data out of objects. And once again, you can see it's dealing with the X position variable, and it will pull the current value out of the X position variable for the user. Let's trace some code that uses this class enemy. Remember, the class is the blueprint or template for creating an object. Once you build a class, and you've got to do that first, you can now start building objects out of that class. And that's what this code is going to do. It's going to build an object out of class enemy and use that object. In a way, you can think of a class as creating a new variable type. You know, we have the int type, and we have the float type, and we have the string type. And now we have an enemy type. And we can assign a variable or an object to that enemy type variable. Remember, objects are runtime entities. We're going to have to run the code to create the object. This object will not be created until the program executes. We're going to use the class enemy to build an object. Breaking down this code into little pieces. What is object? $object in this case is what we call a reference variable. It's going to allow us to access the object that we created. Let's create that in computer memory first and go out and build the object. When we execute new is a keyword in PHP. It's a command that says I want to build a new object. I want to allocate some new memory for an object. What we're going to do is build a new enemy object. New will go ahead and allocate the memory, and that's why I drew this picture of the object here. This is the memory that gets allocated. Since we are building an object, it calls the constructor methods. Remember, constructor methods run first. So this call to new enemy will come over here and execute the underscore underscore construct method. And the construct method will help us build our object. As the code executes, you can see what happens. We're going to do $this arrow x position equals 0. Well, what we're accessing here is the $x position variable here declared at the top. What we're doing is saying I want the default value of my x position variable to be set to 0, and follow the arrow. See the 0 that goes into the x position variable? Objects have variables, and we're assigning values to those variables. What does this mean? This literally means this object. I want this object's x position to be set to 0. And as you can see over here on the diagram, this object's x position is set to 0. Next line of code, I want this object's y position to be set to 0. And you follow the arrow and you can see that this object's y position variable gets set to 0. And finally, this object's health variable gets set to 0. Excuse me, said that wrong. Set to 100. Follow the arrow. Remember, 100 is full health. You should start at full health. And we'll set health to 100, and you can see this object's health variable gets set to 100. That's typically what constructors do. They build the object and set the initial values of the variables. The variable $object is a reference to an instance of enemy. You can see my underline here is under the equal sign here, because after we were done building the object and running the constructor, we then assign that object to the $object variable. I also drew a line from here to here. $object is technically not the memory for the object. It's a reference or a pointer or the location of where the object is in computer memory. And that equal sign says we want to reference that object that we built in computer memory using this variable $object. It's the way I want you to visualize it, as $object is a reference to the chunk of memory that represents this enemy object. Let's use the object that we just built. Let's go to $object, and again, there's that arrow. That's the same arrow that we're using over here. I want to go to the $object. The arrow kind of says go inside it and execute a method. Remember, an object has variables and methods. We're going to go inside this object and run the setXPosition method. And we're going to pass it a 50 as an argument. Again, follow the line. We're going to go execute this method over here as part of this object. The 50 that was passed as an argument gets set to the parameter x. When I say $x is assigned to this object's x position, follow the arrow and look what happens. The 50 gets put in the x position variable. So see this 50 over here? It came into that variable there. From that variable, it went into x position. That's what setters do. They put values in objects. An object is a variable that can hold many different values, and we're putting into the x position variable this value 50. Setters put new values into the object. This method is going to finish and return back to the next line of code. SetXPosition is done, and we're going to go over here and we'll create a variable outside the object. This $x is my variable that belongs to this code over here, so I'll set up $x over here. Then after I set up that variable, I'll call object arrow getXPosition. Go to this object, go inside that object, and execute a getXPosition method. Now I can't draw all the methods down here in the object, so I just use the term methods. I'm going to be running one of these methods over here, specifically getXPosition method. Pull a value out of the object. It'll jump, follow the arrow, it'll jump down to this code and execute this code. Inside the code, it's going to return this object XPosition variable. Remember what I said before, getters pull values from the object. The 50 that's in the object is going to be pulled out and sent back to the caller. Return it to whoever called getXPosition, send that 50 back. Now, where's that 50 going to go to? It's going to go to $x. So this returned a 50 here, and we assigned it to $X, and the 50 showed up over here. That's not too complicated, is it? Objects do that a lot. Data flows into them using set methods, then data flows out of them using get methods. Well, there's a simple class. Remember, this is an enemy object. No matter what game you're playing, if you're battling something, you're going to have things coming at you. Enemies, nemesises, things that trying to get you and you're trying to get them. That's what this enemy class represents. Things that are moving about the screen that either you're trying to attack or they're trying to attack you. Constructors. Perhaps it's best to start with a detailed look of constructors. Remember, constructors are special methods used to build objects, or at least help build the objects. Who takes a blueprint and builds a house? A construction worker. What takes a class and builds an object? A constructor method. Constructors often initialize global variables. That's their primary job, is to make sure the values in that object start or get the proper values. Here's two constructors. One of them is a PHP 5 and beyond, and one of them is a PHP 4 type constructor. As I said, constructors initialize the global variables. So inside the class enemy is where I'll build the constructors. Now, if you're programming in PHP 5 or greater, use this __ construct special method. PHP 5 and above says this is the way we should declare and build a constructor method. This is the code that will automatically run as soon as we build an object out of this class. This is the same constructor from the last time, so it's not much different. There's not a lot to go over here. You can see that it's saying this object's x position equals 0, this object's y position equals 0. What if you're not programming in PHP 5? Or you're working on some code that was written before PHP 5 came out? In PHP 4, constructors and class names match. There's a lot of existing code out there that was written before PHP 5. It's very important to know both ways to do it. __ construct did not exist in PHP version 4. This would have been the keyword enemy or the class name enemy. In PHP 4, constructors and class names must match. So if the name of the class is enemy, then the name of the constructor was named enemy. You did not have the special __ construct in PHP version 4. There's a lot of existing code out there that uses this old style constructor. If you're writing new code, you probably shouldn't use it. But if you're working with existing code, you'll probably see a lot of it. I know for a long time I kept doing it the old way, even though I was working in PHP 5, because I just didn't bother to learn the new way to do it. You will see a lot of constructor methods with names that match class enemy. Now, it's backwards compatible. It doesn't matter whether you're in PHP 5 or PHP 7. The old style constructors still work, but you probably should start phasing out using them. In fact, this code is actually not runnable the way it is. You can't mix and match. Right in the same class, I have the new style constructor and the old style constructor. I really shouldn't have done that. If I copied and pasted this code and tried to run it as is, it wouldn't work. It would tell me pick one. Either use construct the new way or use the old style constructor, but you can't use both. I needed to show you both because you'll see a lot of it out there. But again, if you're using PHP 5, try and use the new style constructor. Variable. Constructors assign initial values to the variables or properties. So you can't get away from them. You're going to have to set values in those. It's not the only job of a constructor to set values in these variables, but it is one of the primary jobs of the constructor to assign values to these variables. Here are two examples of constructor methods. One is the new style PHP 5 or greater style constructor, and one is the old PHP 4 style constructor. Now, there's certainly more methods in this class. They're just not shown, so I can concentrate on constructors. I don't want to put a whole bunch of code in this class and sort of lose the constructors within that code. Also, keep in mind that only old code uses the second example, and you can't mix both types in the same class. if you're writing new code, you should use the new style. If you're working on new code, you will see the old style code. This is sometimes called the default constructor, the constructor with no parameters. Default values, put default values in object variables. I don't want to say almost always, but quite often that's what you do. You build a default constructor that puts default values in there. All this is saying is all new enemy objects that are built are going to be at coordinate 0, 0 on the screen and have the value of 100. This code might do more than just this, but that's primarily what a default constructor does, put default values into global variables. This is a PHP 4 style constructor. Put optional here. I want to say don't do it both ways. You can't have these two different style constructors in the same class. If you're going to use PHP 4 style constructors, you cannot use underscore underscore construct. You just can't mix and match the two styles. What this is going to do is allow the code creating the object to provide values for the object variables. Doing it in a slightly different style just to show you an option. If I really wanted to take these parameters and put them in here, I could and do the exact same thing. I just don't have the space to do every different combination of constructor. We'll also look at the clone keyword for creating a new object. And again, there's more stuff in this class. I'm just showing the constructor so we can concentrate on that piece of it. Here's some code that uses that class enemy, to build objects, and we're going to build objects in several different ways to show you the different options. Different constructors make a big difference when you create the object. The first one I'm going to do, I'm going to break down this line of code into its little pieces. $object1 is going to create a reference variable. Remember, this will be the variable we use to access our object. And in order to create the object, we'll execute new enemy. In PHP 5, this would call underscore underscore construct, the special PHP 5 constructor method. It'll allocate the space for the object and then execute the constructor method, and that's what the arrow is showing you. I'm going to go run this method right now. Inside the method, we'll set this object's x position to 0. We'll set this object y position to 0, and we'll set the health variable for this object to 100. Once it's done building the object, it'll return back to the caller. And again, what does this equal sign do? It assigns this reference variable to that object. The variable object1 is a reference to an instance of an enemy object. And that's what that first line of code does. It builds the object, puts values in the variables, and then references it. Let's drop to the next line of code. Now I've kind of sped it up here. I created the references and the objects and attached them all in one statement. I don't want to sit here and do each micro step one at a time. I built the whole object here so it goes a little quicker. But we still have to call the enemy constructor. Now again, this is the constructor with 3 parameters, PHP 4 style. Remember, it's backwards compatible, so even if you're programming in PHP 5, you can still do constructors this way, but you can't mix and match the two techniques. Backwards compatible means you'll still see a lot of code like this out in the field, so I feel I have to show you this old style. Also notice we have arguments this time, 50, 175. These arguments will be sent to this constructor and assigned to these variables. Keep in mind, you could done the same thing up here and passed arguments right there. It's just I have to show it to you both ways, so I'm showing it with 2 different constructor methods. We're going to pass those arguments and assign them to the parameters. This time when we run, however, we're going to say this object's x position equals parameter x. That 50 we sent as the first argument is going to be routed to and sent to the x position variable of the object. We like to do constructors like this when we know the value of the variables. We'll pass the values of the global variables of the properties as parameters and we'll assign them directly into the object. $y is the second parameter, so the second object 100 gets assigned to y position. Look at that. This object's y position variable equals the parameter $y. The 100 that was sent here is put into the X position variable. This allows the user that's building the object to set its variables while he's constructing it. Very handy to have. Again, we'll go to this object's health variable and set it to $H. $H is the third parameter, so that third argument, 75. Technically, this arrow is wrong. Technically, this arrow should point to $H, and then from $H to the health variable. But that's what we're doing here. You can build a constructor with or without parameters. You can do it PHP 5 style, or you could do it PHP 4 style. I can't show you all the different combinations here, but these are two good examples. A constructor that has no parameters and sets default values, and a constructor with parameters that allows you to assign whatever you'd like to the object's property. But notice what both of them do. Both of them initialize those global variables or initialize those properties. I want to show you a third way to create an object, and that's using the keyword or command clone. Built into PHP is this command clone, which does as the name implies. It creates a copy of the object. I'm going to say $object3 equals a clone of object2. And it simply says copy it. Make an exact duplicate of object2 and use object3 as its reference variable. I'm breaking this out into steps. Clone is doing all this work, but I kind of want to show you all it does. We're cloning object2, so after allocating space for object3, we are going to move X position over from object2 to object3's variable. We're going to move Y position from object2 to Y position of object3. Again, all of this is happening through the clone command. The clone command is doing all of this. Finally, we're going to copy the 75 from object2 to object3. As the name implies, we're making a dead nut copy of object2. And of course, when the clone is done, the object3 reference will point to the new separate object. Object3 is a copy of object2. One thing I have to stress about this code is generally you pick one of the ways to do it, right? I'm showing 3 different ways to build a new object. Calling a constructor with no parameters, calling a constructor with parameters, cloning an object. Make a new object out of an existing object. For the same object, you probably won't use all 3 techniques. PHP does not support overloaded constructors, so you can't have 2 constructors in the same object. But I wanted to show you both ways, and I didn't want to do 2 slides. Moving on. Those are constructors. The big question when you're building a constructor is PHP 5 and greater or PHP 4. Which style do you want to use? Next slide. Let's look now at designing a class. You know, experience is the best teacher, and as you get more and more in programming and do more and more of it, you'll learn how to build a class. But for a beginner, how do you think about the class and object you're going to build? How do you design it and create it? What I'm going to do on this slide is to discuss the thinking that goes around building a new class and creating an object out of that class. Create a class object, you need to come up with a set of properties and methods, or variables and functions. You need to design a class before you type in the code. It's never a good idea to just sit down and start typing out code. You want to think about it before you do it. And that's what this slide's about. Thinking about what I want to build before I build it. What I usually do when I'm going to design a class is before you type in the code, I create 2 lists. List number 1 is what the object is. What is the information or data that describes the thing I'm trying to build? The things that describe what the object is, that's the variables or the properties. Then the second list I build is what does the object do? What the object does. I write down a list of the things I want the object to do, and that's the functions or methods of the object. The variables are what the object is, and the methods are what the object does. Let's build this example of a class gun and see how that works. Again, this is a video game gun. This is not a real gun. This is a video game gun. And what do you want your video game gun to do? What data or information describes a gun? Well, there's a type of gun. Is it a pistol? Is it a rifle? Is it a shotgun? What type of gun is it? That's an essential piece of information that describes what a gun is. Then I need a caliber. Guns have barrels, and the barrels have different diameters. In the English system, we have a 36, which is a 0.36 inches. We have a 45, which is a 0.45 inches. In metric, we have the 9 millimeter, which is a simple 9. What is the size of the barrel or the diameter of the barrel of the gun? That describes what an object is. Guns have ammunition. So we're going to declare a variable ammo and how much ammo is currently loaded into that gun. This is not a complete list. There may be some other information that describes what a gun object is, but what I want to stress here is what key or most critical information that describes what a gun is, that's what we're going to put in here. And ammo is a dynamic thing. If it's fully loaded, it might have 12. If you fire off a few rounds, it might have 9. If you empty the clip, ammo could go to 0, and the next time you press the trigger, no bullet will be fired. What doesn't belong in this list? What doesn't belong in this list is a variable like I just dynamically added there, private temp. What does $temp have to do with a gun? Nothing. If it isn't a piece of information that describes the object that you're building, it probably doesn't belong as a property of the class. Remember, this is the key information that describes the thing you're building. When I see a bunch of variables like $temp or $data or $I say this person doesn't understand objects. $temp does not describe what a gun is. It does not belong as a property in this class. Get rid of it. Push. Variables should be the core information that describes what the object is. For a gun, it's the type of gun, the caliber of the barrel, and how much ammunition is currently in that gun. If I was building a car class, it'd be information like the make and the model and the year, maybe the mileage of the car. If I was building a book class, well, what describes what a book is? The title of the book, the author of the book, the number of pages of the book. That is key information that describes what a book object is. When you're designing a class, think of the things that describe the object you're building, and those are your variables. What about the methods? What a gun object does? What action does a gun perform? Well, a couple of things I want a gun object to do is I want to be able to create gun objects. Video games are replete with examples of picking up a weapon here and picking up a weapon there, and people acquiring weapons, and even mods that allow you to add new weapons to video games. One of the things we're going to have in most every class, but in the gun class, is we need a way to create a new gun object. A constructor is almost always part of the methods of a class. Of course, gun objects fire. We want to be able to fire that weapon. Gun objects need to be reloaded. If you pick up some ammo, you want to load it into your weapon. This is not a complete list. I don't have the room to build a full and complete and total class with a bunch of variables and a bunch of methods. It's a limited list, but that's the way I want you to think at this point. What is the core information that describes what the object is? Those are the variables. What do I want this object to do? That list is the methods. I want to be able to fire a gun, so I need a fire method. I want to be able to reload a gun, so I need a reload method. Let's look in a little detail here. My method to create a gun object is PHP 5 style constructor. I want to be able to fire a gun. I want to be able to reload a gun. The list of things that the object is defines the properties or the variables of the class. The list of things the object does defines the methods or functions of the class. And when you're ready to design a class, when you're ready to write a program to create objects, sit down and write down these two lists, and that will give you your basis for the variables and methods of your class. Primitive versus reference types. Objects are a different beast altogether. Objects are different than other variables, so we can't think of them exactly like we do other variables. Yes, objects are variables, but they're different kinds of variables than non-objects. Now, a primitive type, I'm basically saying a non-object variable. A reference type, I'm talking about an object variable. Primitive types are not objects. Variables come in two flavors. Primitive types, which are not objects, int, float, string, boolean, are some examples that we've used already in this class. They generally take a small amount of computer memory. Then the reference types are the objects, things like game or enemy or gun. That means memory has to be allocated for the reference and the object. Remember, objects take a chunk of computer memory, plus they have these reference variables that allow us to access them. So let's trace some code and kind of see the difference between objects and non-objects. I'm going to just create a variable $score here. You can notice that I'm not even assigning it a value. I'm just saying $score semicolon. That will allocate space for a variable. The question marks kind of indicate that I haven't assigned it a value. It's an empty variable or an undefined variable. If this was a local variable declared inside of a method or a function, it would not be created until that method runs. And of course, this way it has an undefined value. Now, what if it was a property variable? If it was a property variable, it would be allocated when the object is created. If this was a variable declared at the top of a class, it gets allocated when the object is created. Let's do the same thing for a variable money. All I'm going to do is allocate or create a variable called money. No initial value, so it's undefined or empty value. That's what the two question marks indicate. Again, if it was a local variable, this would not be created until the function that had this local variable ran. However, if it's an object variable, it'll be created when the object is created. Let's create a variable rank and assign it an initial value b. This is how I prefer to create variables. I always give them a default value. I don't see the reason of having an undefined variable. Let's put something into it. We're going to put the value b into this variable. Technically, this is a string containing one letter, the letter b. Again, if this was a local variable, it would not be created and would not contain the b until the method ran. If this is an object property, it will not be allocated and will not contain the letter b until I build an object, and then this will be part of the object that I build. There's no doubt whether this is local or property, this will have an initial value of b and I can use it immediately. This is how I like to create my variables, with initial values in them. I'm going to assign a score of 100, assigning the value 100 to the score variable. Values are stored directly into primitive types. Notice how I drew this arrow. The 100 that I'm assigning is going straight into the memory for $score. That's how primitive variables work. I'm going to assign to money 24.50. I'm going to put it in the money variable. Again, notice the line, the 24.50 is being inserted into $money. Now I don't have a line from rank because I already assigned it a b, but look at these three variables, score, money, and rank. They all contain the values that we stored in the variables, and those values are stored directly into the primitive variables. Objects is different. Game is a class. $game would then be a reference to a game object. There's no initial value for the object property name. I'm going to build a game object, and in the constructor of the game object, apparently it didn't set the value of the name variable. I'll build a $game reference variable and point it to this game object, which doesn't contain any data at the moment. Looking at this next line of code, $game arrow set name of Mario. I want you to understand that the value Mario is not stored in the variable $game. The variable $game contains a reference to an object, and that's where Mario is going to be stored. So if you follow the arrow both here and here, go to the $game variable, which is this. The arrow says go inside that object. Go inside the object the game is pointing to. In this case, set name to Mario, and Mario shows up in the name variable. You see that arrow? It kind of means the same thing that arrow means. It says go into this thing and put something into it. Set methods put new values into objects, and the data Mario is stored in the object. Again, up here 100 is stored directly in the score variable. Down here Mario is stored in the object, not into the game reference variable. Set up a new variable. This time I'm going to assign it a value null. Null basically means no object. Enemy is a class, and what I'm creating here is a $monster reference variable. $monster is a variable that's going to point to an object. However, the initial value of null indicates the object has not been created yet. I haven't used the new operator yet, so right now $monster is not pointing to an object. That's what we'll do on the next line of code. $monster equals new enemy, and I'm going to pass it some parameters. This is the constructor from the previous slide that talked about initializing the variables. Assigning a value to the monster reference variable allocates memory for an object, then connects or points that reference to the objects. The values 20, 40, and 50 are not stored in $monster. The location of an object is stored there, and then the values are inserted into that object. You can see that first argument 20 got inserted to X position. The second argument 40 is in Y position. The third argument 50 is in $health. That is how a constructor works. It puts new values into the object. In this case, the constructor must have 3 parameters because I'm calling it with 3 parameters. Notice the 2 different ways to create an object reference. Use null to create a reference without an object. So at the top of the code, you know you're going to need an object. You just don't have one for it yet. You can declare your variables and assign them null. Then later in the code, you can create the object itself. And again, that equal sign on the second line is not an accident. You know that object that I created here on the right side? I want monster to access or reference that. One more example. Let's declare and assign an object to the weapon reference. This allocates memory for both the reference and the object, then connects or points the reference to the object. The values you see in here are the defaults from the gun class constructor shown on a previous slide. Default constructors often put initial values into the global or property variables. It built an object assigned pistol, .45, and 6 to the variables, and then see that equal assignment operator there? It says take that gun object and assign it to that reference variable $weapon. Primitive types like int, float, and string are fixed amounts of memories, values stored directly into the variables. Reference types need memory for the variable and the object. The value in a reference points or refers to the object in computer memory. I don't assign values like Mario to the game variable. I assign it to the object that the game variable is pointing to. I don't assign pistol to the weapon variable. I assign pistol to the type variable that weapon points to. Alright, let's look more in detail about private versus public and why we use one or the other. I know I've been using them all along in this lesson, but let's get specific on why and how we use them. The keywords public and private specify access mode of a variable method from outside the class. Public means everyone should be able to access this element. Anyone can call a public method getYear in this example. Private means very restricted access. No one outside the class can directly access the private year variable. This is a PHP 5 feature. Unless you're programming in PHP 5, you won't see the keywords private or public. Usually, the class is assumed to be public. You do not put the keyword public on the class, but it's public. That allows others outside the class to build objects from it. This would be code that executes from another class and file. It's all about, are you code inside the class or are you code outside the class? Public means code outside the class has access to it. Private means you don't. So clearly, if we're going to build objects, this has got to be a public class. And in other computer languages, you would specify this as public, but in PHP you don't. Just assume the class is public. Private will affect the code above and determine if it can directly access the variable year. This is the code outside the class. Private will not affect the code inside the class car because it can directly access the year. This affects a lot of things, so follow with me on this slide. Square box is around private $year. It says the class car wishes that only it gets to directly access the year variable. So you can see inside the same class, we're accessing the year variable. We're saying this object's year variable should be set to this. We're saying this object's year variable can be returned. Inside the class car, you have full access to the year variable? Where don't you have access to the year variable? Outside the class. If you look at these two arrows over here, this code is outside the class car. So I build a car object and then I immediately try to change the year variable. Nope, can't do it. This is an error. Because the variable is declared private, objects cannot change its value directly. The object cannot change the value of the year variable. What can it do? Well, what it can do is call what's called a set method. I'm going to go to this object and call it setYear method. The setYear method could go in and change the value. Same thing when I want to access the value directly. See this arrow here? Object arrow year. Cannot do it. Because this code is outside the class, it can't get to that private variable over there. Let's trace the code and we'll see what we mean. Let's build an object. Again, this is code outside the class car. The code on the left side is inside the class car. The code on the right side is outside the class car. Private and public determine what the reference variable object will be able to access directly. Since car is a public class, we can create an object directly out of it. No problem at all. And there's my car object there. Basically an empty car object at this point. I'm going to go to the next line of code and I'm going to try to use the $object variable to access the year variable. Access mode private means code outside the class cannot directly change year. This would be a syntax error. This code would not compile. This code will not run. It will light up in red and tell you you cannot do this. Private means only inside the class. This code on the right side, outside the class, cannot access that private variable. What can it do? It can call setYear. By calling the public method setYear, it can request to change the private year variable. I'm going to go to the $object variable. The arrow says go inside of it and run the setYear method. It's going to jump over here to setYear and execute. Inside setYear, this is what we call a setter. The method was designed to change the value of the private variable. Notice how a proper setter verifies the input. Cars weren't built before 1900. You can't buy an 1832 Studebaker. It doesn't exist. So it's going to make sure that this argument, this parameter, is greater than 1900. Well, 2016 is greater than 1900, so that's a true statement. Also, it doesn't want to get too far into the future, so it's going to make sure that the parameter is less than 2035. I'm in the proper year range for a car variable. This is going to be a true statement. Since my parameter appears to be good, it's going to go ahead and execute. This object's year variable equals the parameter $year. And the 2016 that I sent as input is going to be inserted into the object. That's what a good setter method does, is it accepts a parameter, and if it's good data, goes ahead and changes the global variable. Notice on the left side, inside the car class, I do have access to the year variable. But over on the right side, outside the class car, I don't have direct access to the year variable. That's why I have to call a set method. And again, that's what a good setter does. And that's why we have this private and public. The problem with making everything public is then people can put bad values into the object properties. What the setYear does is it acts as a guard, a sentry, and makes sure that any data that goes inside the object is good data. And that's what this if statement says. If this data is good, go ahead and set the private variable. The function setYear return, and we go to the line below it and execute the line below it. Again, I will attempt to erroneously access the year variable. I want to grab a value out of the year variable and assign it to this local $the year. Again, I get a big fat error. Now, why do I get a big fat error on this line of code? Because this year variable is private, and outside the class, I have no access to that private variable. Again, a syntax error. This code won't run with that line of code. What do I do? How do I get access to the data stored in the object if it's private? By calling a public method getYear, you can request the value of the private year variable. What I'm going to do is go to the object. Again, the arrow says go inside that object, run a method. The method I'm running is getYear. This arrow is saying, hey, let's go run this function. This function likes me. It will send me back the value in the year variable. Again, I'm inside the class over here. I have access to the private variable. The 2016, I'll return it, and I'll return a copy of 2016 to the user. When it returns the value in the private property $year to the code outside the class car, then we can assign the 2016 that was sent back to the year variable. Are you getting the picture? Private variable means you have to ask to change it. A private variable means you have to ask for the value. And if it wants to give you the value, it will. And that's what it did, and we assigned it to the year. Just to show you why we're doing this, to show you how the private variables guard the values stored in an object, let's call setYear with a completely bogus argument. Year was a public variable. We could do this line of code up here all day long and put a -2 in the year of the car. But what does a car -2 mean? There's no such thing as a car built in the year -2. So what we want setYear to do is be a good set method and make sure that the data is good. Now when the parameter is -2, year greater than or equal to 1900 is false. Doesn't matter what the rest of this is. This is a false statement. As a false statement, it's going to jump to the else. It's going to skip the assignment and print out that was a bad year. Notice how the -2 was not assigned to the year variable. Instead, the code just output bad year -2 to inform the caller that -2 is not a valid car year. That's what private variables do. They protect your data and make sure that no bogus information gets stored in them. Private variables guard the values stored in objects, preventing what we call garbage in, garbage out. This is one of the oldest statements in computer science. If you allow garbage data into your computer program, you'll get garbage data out of your computer program. If you allow garbage values to be stored into your property variables, you will get garbage out of your objects. Always make your variables private and then write a set method that makes sure the data that goes into them is good. The get and set methods form what we call a pattern, the GetSet pattern. And let's look at that pattern. Let's build a more robust class car. Now we already use the year variable, so we'll use a couple of different variables in this class car. The make and the model of the car. Is it a Honda Civic? Is it a Toyota Camry? Is it a Chevy Volt? We don't know. We're going to keep track of the make and model. Pattern is something that repeats itself. One pattern that you'll do in object-oriented programming is variables private, methods public. That's a pattern. In general, not absolutely, but in general, we want to make our variables private and our methods public. That means we need get and set methods, or getters and setters, that also follow a clear pattern. To show the pattern, I will display get and set methods for each variable. Since that will take too much space, I'll only show one set of get and set methods at a time, and then I'll flip over to new ones. All of this code is in the same class, it's just I can't show it all at once, so I'll kind of substitute new code in when I can. Let's start with the private $make. I'm going to keep track of the make of the car, Honda, Toyota, Chevy, Ford. Set methods insert data into objects. The pattern for a set method is set and the name of the variable. Underlying the make variable, set make is the one that should allow me to assign a new value to the make variable. Get methods pull data from objects. The name pattern is get and then the name of the variable. If I have a private make variable, I generally write a public set make and a public get make, so that I have access to that private variable. Set methods have an input parameter, usually the same type as the variable it's setting. What I'm doing is I'm requesting to put a new value into the make variable. So I have to send input to set make to say this is what I want to put into the make variable. Get methods are the opposite. They should have an output or a return value. Again, usually the same type as the variable you're getting. Get methods return what's stored in the make value. Set methods always have an input. Get methods always have an output. Again, set methods assign the input parameter to the private variable. Anyone from outside the class can change the value in the make variable by calling setMake. A value will come into MK, and from MK it'll go into the make variable. Get methods flip it the other way. They return the value of the private variable. Since make is declared private, no one can directly access it, but you can go to an object and ask it to return what is currently stored in the make variable, and that is what this code is doing. New code. What I just did is I switched over to the model variable. I substituted in set model and get model. Again, I don't have room to do all these set and get methods, so I'm popping in some new code. Set methods, insert data into objects. We're going to call this set model because it's going to put a new value in the model variable. Get methods pull data from objects. The pattern is going to be get model. See the pattern? All I changed. For make, it was set make, get make. For model, it's going to be set model and get model. Set methods have an input parameter, usually the same type. Here's the new value of the model that I hope to insert into this variable. Get methods have an output or return, usually the same type, so I'm going to send back what's in the model variable. The pattern holds. If $model is a string, set model has a string input. Get model has a string output. Set methods assign an input parameter to the private variable. Get methods return the value of the private variable. Notice how set model follows the same pattern that set make did. Notice how get model follows the same pattern that get make did. Once again, I'm swapping in new code and a new type this time. Cost. Cost is a number. Cost is a numeric value, whereas make and model were strings. Cost is a number. Set methods insert data into objects. Following the pattern, we should call this set cost because we're setting the cost variable. Get methods pull data from objects. Following the pattern, we're going to call this get cost. Are you seeing the pattern? All we're doing is changing the names. Set methods have an input parameter, the same type as the variable it's setting. Get methods have an output or return type, the same as the variable it is getting. The pattern holds. If cost is a float, set cost has a float input, and get cost has a float output. A good setter should verify the input and prevent garbage in, garbage out. Set methods assign the input parameter to private variable. So what I'm going to do is just make sure that the cost is a reasonable value over 0. We don't want a negative cost. Cars don't cost -2. So we want to make sure that this is a positive number. Get methods return the value of the private variable. Once again, the pattern holds. Only the names and types change. The only thing I'd say about this slide is I should have better setter checking. All three of these set methods should have verified the data was good. So for set make, it should have verified that it was a valid make like Chevy, Toyota, Honda. Once you know the pattern, writing more set and get methods is easy. Code generators easily write them. The only thing I want to remind you to do is better input checking in set methods. I did not want to do a whole bunch of set method code in here, but think of objects as mega variables. They can store multiple pieces of information, and set methods put values into, and get methods pull values out of that object. Static variables and methods. Let's cover something called the keyword static. I think it's important for understanding objects, so now's a good time to do it. A simple way to think of static is no object required. You don't need an object to access a static variable. You don't need an object to access a static method or run a static method. Static variables do not require an object. Static methods do not require an object. That's a very simple way to look at it, but it's a start. Statics are sometimes called class variables or class methods. They are part of the class enemy in this case, not part of the objects built from enemy. Simplified class enemy here so you can focus on static. There would of course be more variables and methods in the full version of class enemy, but I just need enough to show you how it works. Look at the red underline. Private static $count equals 0. As a static variable, one and only one copy of count will be created. Create 100 enemy objects, we'll still only have one count variable. As a non-static variable, there'll be one copy of health for each object created. If we were to create 100 enemy objects, we'd have 100 health variables. See the difference? Static says I want one copy of the count variable. Non-static, like health, means I want one per object. When you create a static variable, you get one variable for all the objects to share. You create a non-static variable, you get one variable per object. Static variables are shared amongst all the objects, whereas non-statics, they all get their own copy. Statics can be used to communicate. It means objects can talk to each other through static variables because they're sharing the same variable. Something put into a static variable by one object can be read by another object. One of the ways I've described statics before is think of your bathroom. The towel next to the sink is a shared towel. There's one towel and everybody dries their hands on the same towel. So if 4 people share the same bathroom, they're all using the same hand towel by the sink. That is a static towel. But toothbrushes are non-static. There should be one toothbrush for every person that uses the bathroom. If there's 4 people using the bathroom, there should be 4 toothbrushes. If there's 4 people using that bathroom, there should be one hand towel and everybody uses the same. Same thing for static and non-static variables. Static is shared, non-static is not shared. I've also already drawn the variable. Look down here at the bottom, just above the logo. Enemy : $count is 0. This variable gets created even before we create an enemy object. Farther below, you can see the red line. We have a static function, public static function getCount. A static method can run using the class. Use the class name, then a : and then name the static method you want to run. This one would be run through enemy : getCount. Notice how I'm not using an object to run this method. I'm using the class enemy to run the static method. Remember, static methods don't require an object. You use the class to execute them. A normal non-static method is run using an object. You use the object name and the arrow operator to execute the method. So this is normally how it's done. $E1 equals new enemy. E1 would be the object. And then I'll say E1 arrow getHealth to execute the getHealth method. We've been doing that all this lecture, building objects and using objects to run method. Now, I didn't show you the getHealth method. There's not enough room in here. But any non-static method, this is how you run it. You create an object and then use the object to execute the method. An object is not required to run a static method. An object is required to run a non-static method. getCount is static. I can use the class enemy to run getCount. getHealth is non-static. So I have to use an object to run getHealth. Do you see where I said no object required? I don't need an object to run a static method. Let's execute some code that uses class enemy and our new static variables and methods and see how it works. We're going to trace this code. Remember, static means no object required. Look what I'm doing. I'm going to run getCount before an object is created. The static variable $count exists before an object is created. The $count equals 0 means it'll have an initial value of 0. This print statement is executing long before I build an enemy object. We'll send the current value of count, which is 0, back to the caller of getCount, which allows the print statement to execute. And when the print statement will execute, look what comes out. Notice how this is done without an object. Static methods do not require an object. Static variable count exists before the first object. Get count is going to find that 0 that was initially set in there and output a 0. Do you see where this 0 is coming from? It's coming from this call to get count. Let's build an enemy object. $E1 equals new enemy. Let's create the very first enemy object, E1, and run the default constructor. As the arrow indicates, this is going to go execute this constructor method. We're going to set this object's health variable to 100, and you can see down here in the object we've got 100 in the health variable. Note, health is a non-static variable. Each object will get its own copy of the health variable, and E1's copy is set to 100. Then we'll do an enemy : $count ++, and we'll add 1 to the count variable. And there's a 1 showing up in our count variable. We've built one object. Count should be set to 1. We return from the constructor and we execute the code below the building of E1. Now we got a new print statement here, and we're going to call enemy : get count again and execute this static method. When this static method executes, it's going to return the count variable. It's going to send the current value of $count 1 back to the caller. At the time this is executing, there is a 1 in the count variable. That 1 is sent back. We execute the print count is, and out comes a 1 on the screen. I drew the arrow here because that 1 is coming from this count variable. Get count called here. That sent the 1 back, and then the 1 got put on the screen. To really see how static variables work, we need to create more objects. Static variables are 1 copy for all objects. Non-static variables are 1 copy per object. Let's see how that works. Let's create an E2 object. To create the E2 object, I'm going to call the constructor, the default constructor, and go off and execute this code. You can see it automatically allocates space for E2. Notice how we've created another health variable. Health is non-static. Each object gets its own copy of the health variable. Remember, each of these is an enemy that's attacking you. If there's 3 enemies, they all could have a different health value. Each object gets its own copy of the health variable, and E2 copy is set to 100. I now have built 2 enemy objects, and notice how I have 2 non-static health variables. I have E1's health variable, and I have E2's health variable. However, look at static variable count. It is not part of the object. It existed before the first object. Adding 1 to the 1 copy of count changes it to 2. I don't build a new count variable every time I build a new object. Why? Because it's static. Static means 1 copy for all objects to share. We bump the count to 2 in that 1 copy, and we return from the constructor. When we get back to the constructor, we'll print out what the count is. During the print, the value of count is coming from the only copy of the count variable that exists. Also, using the object E2 instead of the class enemy to execute get count. What happened here? Count is showed up on my output, then E2 arrow get count. Go to the E2 object and access the count variable. Well, remember, count is shared by everyone, so even E2 can execute get count. It is perfectly okay for an object to execute a static method, and that's what that object did. It returned what the current count was and a 2. Notice the arrow. Where did I draw the arrow? Because this 2 on the output is coming from that variable $count. That static variable $count. That shared variable $count. Again, to really see how static variables work, we need to create more objects. Let's create a third object, E3. And what we're going to see for the non-static health variable, we'll create a third health variable. That's how non-statics work. Every object you build gets its own copy of the non-static health variable. And we'll reference that third object with the variable E3. We'll run the constructor for E3. When we run the constructor for E3, we'll go this object's health variable. So this E3's object, its health variable gets set to 100, and 100 appears in E3's object. Once again, we'll bump enemies count variable. That's class enemies count variable. Once again, notice how there's one copy of the count variable. Bottom line is I've created 3 enemy objects, yet I still have one and only one static variable named count. That's the way statics work. As soon as you put a static in front of a variable name, that means I want one copy for all the objects to share. And that one copy just got bumped to 3. When I come back and do the print statement, it'll say the count is, and it'll again use the class enemy to run get count. During the value of print, $count is coming from the one and only copy of the count variable. It's a 3. Notice where I drew the line from. This 3 from the count variable gets sent by get count and output to the screen a 3. Are you seeing it? The difference between static and non-static? The non-static health variable, 3 objects, I have 3 health variables. The static count variable, 3 objects, I still only have 1 count variable. And frankly, it doesn't matter. I could build 100 enemy objects. I'd still only have 1 count variable. That's what static means. Static methods. The beauty of a static method is it can run without an object. Way up here on the top of line, we ran get count before we ever built an object. That is a clear advantage to a static method. I'm allowed to run a static method before I built an object. But what a static method cannot do is it cannot access non-static variables. Over here in red, I put a this object's health variable equals 10. It's in red because I can't do that. Why can't I do that? Well, if you think about it, health is an object variable. The only time you have a health variable is after you built an object. But static methods need to run without an object. It's sort of a chicken and egg problem. You cannot access an object variable from a method that runs without an object. It doesn't make sense. You can only use local and static variables in static functions. You cannot access object variables in static functions. That's it for static variables. Again, the thing that I always remember is statics don't require an object. Static variables are not part of the object, therefore you don't get different copies for every object. And static methods don't require an object. I can always run a static method with the class name and the colon rather than using an object and the arrow to run it. That's it for this lesson. Have a good one. See you next one.